Hello, my name is David, and this is the Diophantine equation exercise for CST-215. For this exercise, I was asked to create a Python code that solves a Diophantine equation, ax plus by equals 1, for a given a and b. To do this, I was to create a function that receives two integers as inputs, a and b, to solve the equation for some x and y integers. Because a and b must be relatively prime to satisfy the Diophantine equation where c equals 1, we were asked to return x and y if so, and otherwise return a, b, and their greatest common divisor. Before running you through the code, let me run the program. After running, we see 20 random pair of values for a and b. For the a and b values that are relatively prime, the Diophantine equation is shown, and for the values that aren't relatively prime, their greatest common divisor is shown. The code consists of two functions: the GCD plus function that calculates and returns the x and y values along with the greatest common divisors of two values a and b, and the output function that prints these values in the appropriate format depending on whether a and b are relatively prime or not. Finally, in the main function, 20 random a and b values in the range from 1 to 9,999 are generated and passed to the output function. Now let me run you through the GCD plus function. Now why is this function named with such a weird name? Well, let me explain. This function is named GCD plus because the function implements the recursive Euclidean algorithm to find the greatest common divisor of two numbers, the GCD part, and in addition, the function calculates the x and y values for the Diophantine equation, the plus part. I know. Alright. The exit condition for the recursive function is when a equals 0, where the solution to the Diophantine equation, ax plus by equals 1, is for an x value of 0. Y value of 1, and the greatest common divisor being b. These values are all returned to the previous call. For the case that a isn't 0, the function calls the function itself, but with a new a as the remainder of the division between b and a, and the new b as a. The values returned by the called function are assigned to x and y, and GCD. These values are also returned in the form of y minus b divides a times x for the returned value of x and x for the returned value of y, along with GCD. These are returned until the full recursion stack is reversed. We proceed to the output function, which receives the a and b values from the main function. The output function calls the GCD plus function to get the x, y, and GCD values for a and b. These values are printed according to if a and b are relatively prime. We do this by printing the a, b in the Diophantine equation solution if the GCD is 1, meaning a and b are relatively prime, and printing a, b along with their GCD if GCD isn't 1, meaning that a and b aren't relatively prime. Thank you for watching.